Hi student. Now we are going to start the individual chapter, right? So we have classified this unit into four different chapters. The chapter include column chromatography, paper chromatography, TLC, and then electrophoresis. So now we are going to learn about the column chromatography. So in this, I have categorized this column chromatography in two sections. So this is section one, where you will be seeing about the principal methodology and then packing of the column, and the rest application advantage and disadvantage will be discussed in the other section. So let us see about the column chromatography. So when you see in the picture itself, I have shown the column loaded with the sample and then with the stationary phase. So as we move down the presentation, we will see that how does the column works. So let us see the principle. The principle behind column chromatography is adsorption, in which the mixture of component dissolved in mobile phase is introduced into the column and the component move depending upon their relative affinities. The choice of solvent depend upon the solubility characteristic of the mixtures. So with this we can understand that how does the separation of compound happen in column chromatography. So look at here in the picture, I have shown the introduction of sample, and then you can see the stationary phase, right? So in the very first thing, what we have done, we have packed the column, and we will discuss about the packing of column at the end of this video, where we see that how does the packing is being done in the column. So we have packed the column with the stationary phase, and then we have loaded the sample. After loading the sample, we pour the mobile phase on that. So blue color here shows the stationary phase, and the green color is showing the loaded sample, and the pink color shows the mobile phase. So what happened when you load the sample onto the column, thereafter the separation has to taken place when you pour down the sample, when solvent pour down the solvent. So as you pour down the solvent from the top, what happened, the migration of this the loaded sample happens onto the stationary phase, and then migration happen based on their affinity towards the stationary phase. So I said in the previous class when I was discussing about the how does the principle of adsorption chromatography, the sample which is going under separation spend time both in the mobile phase as well as in the stationary phase. So when they are spending a lot of time onto the stationary phase, or when they are bonded strongly with the stationary phase, they move they move slowly, and one which has gotten a lesser interaction with the stationary phase move faster, or they spend more time in the mobile phase. So look here, the orange color component, right, has a strong interaction with the stationary phase, and the green one has got a weaker interaction. So as you keep down the pouring the mobile phase from the top, what happened with the mobile phase, the green, where there is a weaker interaction, the sample will be moving. So when the sample moved on, it elute first, and later on the orange which has a strongly bonded will be eluting. So this is how the separation happen into the column chromatography. So look here, what are the role of mobile phase, right? So when you are using a mobile phase, it is not only acting as a eluting agent, right? Apart from that, it acts as a solvent, right? Yeah, I mean, and it acts as a developing agent, and it acts as a eluting agent, right? So the mobile phase act as a solvent as well as a developing agent, and it acts as a eluting agent, right? So what does it basically mean, right? So when you are packing the stationary phase, this same solvent system is being used, and when you have to load the sample into this, the sample cannot be directly loaded in the solid form when it is present, right? It must be dissolved in solvent, right? So even that this particular mobile phase is taken, and the sample is dissolved and loaded on that, right? And then later on the separated sample is being eluted from the column. It is also held with the mobile phase. So it acts as a three form, right? It acts as a solvent, it acts as a developing agent, it acts as a eluting agent, right? Some of the well pronounced or well used solvent are ethanol, acetone, water, acetic acid, and pyridine. And here we have arranged, right, I mean the based on the polarity, right? So the polarity of the solvent is highest in the pyridine, right? And then more than in water as compared to ethanol. So this is how the solvent is chosen, right? We'll discuss about the choosing of solvent when we talk about the isocratic solution and gradient solution, that how do we choose the solvent for separation. So this is how it is, and it also depends on the stationary phase. That separation of a compound depend on the stationary phase. So make sure when you are choosing a stationary phase, the particle size must be uniform. The shape and size of the particle must be uniform. It should not be different, right? A stability and inertness of the particle, so that it doesn't react with the sample which you have loaded, right? It must be colorless, so that you can see that the migration of a compound happening if it is colorful, or it should not, you should not see, I mean, because of the color of the stationary phase, we will not able to see the completion of the separation, right? So it makes sure that it is colorless in nature, inexpensive, readily available, and allow free flow of the mobile phase, right? And suitable for separation of mixture of various compound. And these are the ideal property of a stationary phase, which has to be taken care when you are loading the column. So this the generally used stationary phase is classified into the strong absorbent, intermediate absorbent, and weak absorbent, right? So what is absorbent? A substance that is generally porous in nature with high surface area to absorb substance on its surface by intermolecular forces is called adsorbent, right? So it has been classified. So look here, even the example is given, and it has been quoted into the table, that what are the strong absorbent, intermediate absorbent, and weaker absorbent, right? It shows the interaction of the sample which in that separation, how does the interaction form with this. On that basis it has been classified. So the success of chromatography, especially column chromatography, depend upon the proper selection of a stationary phase. If we don't choose the proper stationary phase, the separation may be difficult. It is so because when there is an interaction is so high between the stationary phase and the sample has to be separated, it is very tough to elute out from the column. So make sure that the column which you have taken and in that you have filled with the stationary phase has no too high interaction between the stationary phase and the sample to be separated, and even no so weak that they don't retain onto the stationary phase and move out of the column, right? So looking with this concept, we have to understand that selection of a stationary phase is a important parameter when you are choosing a stationary phase for separation. And also you must be we must take care in a similar fashion when we are doing for the choosing of mobile phase, right? But that we will discuss when we talk about gradient and the isocratic, right? It depends on the following, right? The success of chromatography and the selection help in the following parameter. It help you in the removal of impurities, number of compound to be separated, length of the column to be used, and affinity between the two component, and quality of absorbent tool. These are the success parameter of your column chromatography. So if when you are choosing, you must make sure that all this consideration has to be taken consideration, that I mean, how to remove the impurities, on how many number of component you are going to separate it, how is the length of the column, right? So this all is an important parameter to for the successful success of a column chromatography. So what is the column characteristic, right? The column to support the stationary phase, right? The column which you are taking, it should support the stationary phase, right? And the material is good quality neutral glass and should not affected by the solvent, right? The meaning is that when you are choosing a column in which the stationary phase is loaded, it should not have any interaction between the sample and the mobile phase which you are going to use, right? An ordinary burette can also be used as a column for separation, which is cost effective, right? And the dimension between length and diameter is generally 10 is to 1, 30 is to 1, and 100 to is to 1. It depend upon where the use is and how much is the sample, right? So I mean, it is better always in the lab to use as a 10 is to 1, and the width should be this ratio, right? 30 is to 10 is also permitted, and 100 is to 1 is also permitted. Means if the length is 100 meter, the width should be 1 meter, and if it is 30 meter length, it should be 1 meter, and 10 is to 1. Sometime these are the length and diameter ratio of the permitted column to have a proper separation, right? And in the various accessories also attached at the top, like you can use a vacuum pump so that you can give a pressure to for the solvent move migration, right? Because sometimes the migration of the solvent within that is a very challenging. So you can pop up with the the pressure gauge over from there, and you can give a pressure so that the solvent move little faster. But there is also chance that there is a crack into the stationary phase. See that this all has to be taken consideration when you have been handling with this. So the length of the column also depend, right? Means the if you see into the column chromatography, the length of the column are in a different form. So how to choose the length of the column? There is also called pen column, and you can see in the industry the column is to till the 5 meter to 10 meter, right, or to the height of the building, right? So how to choose the length of the column? The length of the column is chosen based on the following parameter: the number of compound to be separated, type of absorbent used, quality of the sample, affinity of the compound toward the absorbent. Better separation will be also obtained with long and narrow column than the shorter thick column, because of number of plate will always be more. So take into the consideration the longer is always better here, but it should not be too much that it consume lot of time, because time is the biggest challenge in column chromatography. So packing of column, when I discuss about the illusion, I will try even talk about the packing. The packing is in two form: dry packing and then wet packing. So what is dry packing? The stationary phase which you are going to pack into the column is not dissolved into any solvent. It is directly poured into the column and it is packed, and it is tapped so that there is no gap in trapped in between. And in wet packing, what we do, we take the column into the we dissolve the column into the mobile phase, and then we pack it so that the packing is a proper and ideal, right? So generally the packing is done in a wet packing, but there is an advantage of wet packing over the dry packing, right? Then you need to load the sample. The sample loading is also a technique involved in this, so that there is no proper when you don't load a sample proper, there may be concentration of a sample at a particular place in the column. So that what happened, the if it is too concentrated at one place and other side it is vacuumed, the migration of the sample when happen in the column, you will feel like it is not proper, right? So and then there is a development technique called isocratic illusion and gradient illusion, which we'll see into the next section of the video. Till then, thank you, and take care.